Hello, Legacy Sabers. Marsh here. So today we're going to talk about graphing ellipses at the origin. You're going to want your conics foldable, a pen or a pencil, and then I would also recommend three different colored pens, three different colored markers, something along those lines, so it's easier for you to color in some stuff on this information. Ellipses basically are just ovals. They are circles that have different sized radii, or different diameter sizes, either horizontally or vertically. That is what basically the definition of my ellipse is. But first, we need to talk about all the parts of an ellipse. You're like, but it just has, a line, right? There's a lot of parts to an ellipse. So first, we have a center. This would be in the regular color. So in our regular color, we're going to write that we have a center. So that's the middle dot, kind of like how the circle had. Also in the regular color, we have the major axis. The major axis is just the axis that is the longest one. So in this case, on this graph, we have a horizontal major axis because that is the XY, right, left and right. Also in your regular color, we're going to have the minor axis. The minor axis is just the other axis. That's the shorter of the two, that's shorter in length of the two. The other, now changing to a new color, a special color, you have what's known as the foci. The foci on a ellipse are not to the end of them. However, it is on the major axis. It is a distance away from the center of your ellipse. Changing colors once again, we have what's known as the vertices. The vertices are the endpoints of the major axis of the ellipse. And then changing a color for a final time, we have what's known as the covertices. The covertices are the endpoints of the minor axis. So in this case, our covertices were up and down, and our vertices were left and right. Our foci are found for information in that they are the same distance from the center to the foci. They allow you to be able to find the bounce off point of the sides of the ellipse ultimately. They are also useful in real life situations when you're dealing with ellipse in the regard of that. Lots of parts, right? Lots of pieces. So we are going to have to really focus in on these ellipses. The standard form of an ellipse that is in the horizontal position is x minus h quantity squared over a squared plus y minus k squared over b squared equal to 1. Notice the a is always greater than b, which is always greater than 0 for our ellipse that it has a horizontal major axis. Now, you're probably wondering, Marsh, what is this a and this b? Where are they? Because we are assuming, right? H and K center, right? But what is this A and this B used for? Well, we need to be able to find those vertices, those covertices, and those foci, or foci, depending on who you talk to. So the A and the B allow us to find that information. Now, the formula for C, the foci, because there exists another value, the C value. They're going to tell us the value and the sizes of our ellipse. There exists our equation for the ellipse right here. And we also have the formula to find C, aka the foci. A squared minus B squared equals C squared. That A value is going to tell you how far your center is to a vertex. This is also where those colors might come into play. So the color that you used for the vertex on your drawing, maybe you want to do also the same thing as circling the A or putting something along that on the graph. The B value is how far your center is to your covertex. So that A and that B are going to be assisting. That's why the B value has to be smaller than the A, because if it wasn't, then you'd be finding the vertex, not the covertex, because the A has to be the major axis has to be longer, right? Now, the C is not in our standard form. However, the C tells you how far your center is to the focus, both of them. So this C value right here is the same as this C value. I know, lots and lots of drawings, lots and lots of color. Trying to be helpful here on my information. So this is a horizontal major axis ellipse. Let's take a look at what can make a vertical ellipse. So to determine if an ellipse has a horizontal or vertical major axis, you're going to look to see who has the bigger denominator. So if the A, because remember A has to be the bigger guy, is under the X, then you have a major horizontal axis. If the Y has the A, aka the bigger denominator, you have a vertical major axis. Let's keep going here. Let's do parts of an ellipse on a vertical major axis. So again, we have the center of our ellipse. We have the vertical major axis this time. This should all be in the one color. And then minor axis, of course, is the, notice this time it's the left and right because it's the shorter of the two axes. New color, we have those foci or the foci of our ellipse. And then a new color, we have these vertices hanging out there, up and down. And then, of course, with the new color, we have those co-vertices. Notice the co-vertices are along the minor, and the vertices and the foci are along the major axis. That should always happen. That is not an abnormal thing. That is a constant thing that should be happening. And just like the horizontal ellipse, we do have the A, the B, the C stuff going on. So over here, I got my ellipse, I got my vertices, my major axis, all of that information. The A, of course, stands for how far your center to your vertices are again. And that B value is going to stand for how far your center is to your co-vertices. Again, that C value, even though we don't have it marked in, is going to take care of how center to focus, how far that value will be. Lots and lots of values. Let's try actually graphing one of these, shall we? So first thing I notice is, do you see how it's not equal to 1 on the first problem? So let's make it equal to 1. Let's divide everything by 25. So I'm going to divide everybody by 25 here. By doing that, I'm going to get x squared over 25 divided by 25. That's 1. Y squared over 25. And that's going to be equal to 1. So now let's identify our major axis. Is it vertical or horizontal? Well, y has a bigger denominator, which means we are vertical in our major axis. Our center, notice there's nothing with x and y. Just like the circle, when there is nothing with x and y, we were able to say our center is 0, 0. So over here on my graph, I am going to put a dot at 0, 0, and I'm also going to mark it with a little c. So I know that is the center. Now, let's find our a, our b, and our c. Remember, a is the square root of the bigger denominator. So I'm going to square root 25, and I'm going to get 5 for my a. My b is the square root of the second denominator, which would be 1. And then c, we're going to use that formula, a squared minus b squared is equal to c squared. So I'm going to go 25 minus 1. That's equal to c squared. So that would be 24 is equal to c squared. Square root both sides. We are going to get 2 square root of 6, right? Because 4 times 6 is 24, simplified, would be my c value. Now, again, we probably want that as a decimal equivalent. I'm guessing it's very, very close to 5. Probably like, 4.9, something like that. Yeah, about 4.9, approximately. Okay, now I have all the information. I have my A, B, my C. Now I just need to use that information to find the vertices, the co-vertices, and the foci. Now, remember, our A value is vertices to center. So I have 5. So that means my center to my vertices has to be a distance of 5. And since this is a vertical ellipse, I'm going to go up and down that value. So I'm going to go up and down 5. 1, 2, 3, 4, 5. And I'm going to put a V by that. That's a vertex. I'm going to go down 5. 1, 2, 3, 4, 5. And I'm going to put a V by that one as well. Now, writing those ordered pairs out, it looks like to be 0, 5 and 0, negative 5 for those ordered pairs. I'm going to change color here so we can see some red. Those co-vertices, remember that is the B value. The B value tells you how far you're going to find your co-vertices from your center. And since this is a vertical ellipse, I'm going to go left and right. Also, the 1 is under the X. That's how I know it's going to be left and right. I'm going to go 1 left and right. And I'm also going to mark those with CV because those are co-vertices. Those various ordered pairs are negative 1, 0 and 1, 0. Changing colors one more time. Let's go find those foci. Those foci are the C value. Remember, the C value is how far your center is to your focus. So I'm going to, from the center, go up and down because it has to be on the major axis, 4.9. Now, I hear you. You're like, Marsh, that is basically 5. But that is where your vertex is. So I'm going to put a foci right there and another foci over here. And then I'm so cool, I get to actually finally connect the vertices and the co-vertices. Yes! Now, writing those foci values. Well, it's 4.9 up and down, right? So I'm going to say I went 0, comma, but I'm not going to write 4.9. I'm going to write the square root version. So that would be 2 square roots of 6, or 2 times the square root of 6. And I also have the negative version of that. Lots and lots of information, right? Let's try a second one. Again, we're not equal to 1, so let's divide everything by that 72. Make this simplified here. I'd get x squared over 8 plus, 72 divided by 36 is a 2. So I'll get y squared over 2 is equal to 1. So notice, bigger denominator is under the x, which means this is a horizontal ellipse. My center, again, is 0, 0. There is nothing with the x and the y up there. So I'm going to put a dot here on my center. Now, let's find our a, our b, and our c. Remember, a is the bigger denominator, so we're going to square root 8. That is also 2 square root of 2. 2.8, 2.9 is roughly that decimal equivalent. B is the square root of 2. Square root of 2 is a little bit more than 1, 1.4 roughly. And then remember, C, we're going to use that formula, a squared minus b squared. So we're going to go 8 minus 2, which is going to give us 6. That is our c squared. So if I square root both sides, we will get the square root of 6 for our c, which is between 2 and 3, kind of more in the middle, so probably about between 4 and 9, so it's probably about 2.5, 2.4 roughly for a value. Again, Mr. Calculator can definitely help you with getting those decimal approximations. So now, my vertices, remember, that's your a value. We need to go left and right this time, because it's horizontal, 2 square roots of 2, or 2.8, 2.9. So I'm going to go left and right, 2, kind of close to 3. I'm going to put a vertex there. I'm going to do the same thing. 1, 2, a little bit more, vertex. So ordered pairs. I'm going to write them as 1 unit because I technically went plus or minus 2 square roots of 2, right? So I'm going to say I went right, I went left, 2 square roots of 2, comma 0 for those ordered pairs there. I'm going to change my color. I'm going to go to purple for the co-vertices. Remember, that's your b value. I'm going to move square root of 2 up and down. So about 1.4, 1.5. I'm going to mark that with a CV. And then I'm going to do the same thing here, CV. Again, those ordered pairs, they have an x value of 0, but they went up and down 1.5, right? Which is that square root of 2 value. Change my color one more time here. Let's go into a blue. Foci, I'm going to go square root of 6 left and right, because remember that has to be on the major axis. Square root of 6 is roughly 2.5 or so. So I'm going to go to right about right there. That's my foci. One right here. And again, I'm going to write those ordered pairs kind of like I did with the vertices, is it's plus or minus the square root of 6, comma 0 for that ordered pair. And do not forget to connect your dots. Foci are never connected, though, when you draw that in. That is the end of this video today. I know these are a lot of information. We do spend 2 days on these because they do take a little bit. But it is very systematic in how you're finding your information. So once you find all the A's, the B's, and the C's, then you just need to make sure you connect those A, B, and C values to your graph's values. We're going to do quite a bit of example work in class. So until then, I will see you later, Sabers.